Every great invention starts with a simple idea. How does a computer come to life? From these tiny switches, entire systems come to life.
Hello everyone, today we are going to build LogicGates. I am Daniz Ahmadova and I will make AND gate.
I am Emil Humbatov, I am going to make NOT gate.
I'm Ilaha Osmanova, I'm gonna build OR gate. By the way, we are team 8.
First, I connected the breadboard to the power supply module and activated the positive and negative rails. This provides the necessary voltage for the circuit to operate properly. Next, I placed a push button on the breadboard. The push button represents the input of the NOT gate. In digital logic, the input can be either 1 or 0. When the button is not pressed, the input is considered 0. When it's pressed, the input becomes 1. After that, I insert an NPN transistor into the breadboard. In this circuit, the transistor works like an electronic switch. It controls whether current can flow through the output or not. Then I connected the push button to the base of the transistor, so a blue resistor. This resistor is very important because it limits the current going into the base and protects the transistor from damage. For the output, I placed an LED on the breadboard. One leg of the LED is connected to the positive rail and the another leg is connected to the collector of the transistor. The emitter of the transistor is connected to the negative rail. Now, let me explain how the logic works. When the button is pressed, the output is 0. The transistor remains off, the current flows through the LED and it turns on. This means the output is 1. When the button is pressed, the input becomes 1. The transistor turns on and allows current to flow directly to ground. As a result, the LED turns off, which means the output is 0. So the output is always the positive of the input. That's why this current is called a NOT gate. I changed the button and now it works perfectly. When I press it, the LED turns off.
First of all, we plug the power supply into the breadboard. The positive goes to the red rail and the negative goes to ground. Then we place each push button so that it crosses middle gap of the breadboard. Next, we connect one side of each button to the positive rail. In this way, the buttons become the two inputs of the AND gate. After that, we connect a resistor from each button output to the base of a transistor. These resistors protect the transistor base from too much current. Each transistor has 3 legs: the base, collector, and the emitter. The base is the control leg, the collector is connected to the load, and the emitter usually goes to ground. We place the transistor so that its base connects to the resistor. When we press the button, the voltage reaches the base and the transistor turns on. Then we connect 2 transistors with jumper wires. In this AND gate design, the 2 transistors work together so that current flows only if both are on. If one transistor is off, the circuit is broken and the LED stays off. This is because in an AND gate, even one low input makes the output low. Their outputs connect the base of the 3rd transistor. The 3rd transistor controls the LED and acts as a final switching stage of an AND gate. If both first transistors conduct, they allow enough voltage to reach the base of the 3rd transistor. Next, we add a resistor so that the LED does not receive too much current and burn out. This resistor limits the current to protect the both LED and the transistor. Finally, we place the LED on the board. The long leg connects to the red rail throughout a resistor, and the short leg connects to the collector of the final transistor. It makes the transistors act as a switch. Only when both buttons are pressed at the same time, all transistors conduct fully. As a result, current flows throughout the LED circuit and the LED turns on.
First, I connect the power supply. It provides voltage to the entire circuit. Without a power source, current cannot flow, so this is the starting point of the system. Next, I connect the LED, which represents the output of the OR gate. The short leg of the LED goes to ground, while the long leg connects to a resistor using a jumper wire. I use a resistor to protect the LED because if too much current flows through, the LED can burn out. The resistor limits the current and ensures safe operation. Then I connect the transistors. In this circuit, transistors act as an electronic switch. They control whether current flows through the circuit or not. Each transistor has three legs: emitter, base, and collector. The emitter connects to ground, the collector connects to the LED side of the circuit, and the base connects to the input through a resistor. When voltage is applied to the base, the transistor turns on. As a result, current flows from the collector to the emitter, completing the circuit and lighting up the LED. At this stage, the main switching part of the circuit is ready. However, transistors still need input signals. Without voltage at the base, they remain off and the LED stays off. Therefore, I add the push buttons to provide the input signals. I connect two push buttons as inputs. Each push button connects to the positive voltage using jumper wires. When I press either button, it sends voltage to the base of its transistor. To test the circuit, I plug in my breadboard. However, firstly, it doesn't work. After that, I carefully checked the system and I realized that I forgot to connect the emitter of the second transistor to ground. Because of missing connection, system doesn't work. Once I solved the problem, I plug in my breadboard again. As a result, it works. When I press first button, LED lights. When I press second button, LED also lights, and when I press both buttons, it still works.